Welcome back to the Chem 1806 version of our wonderful video sessions that we are going to be making. Today we're going to be talking about the atomic emission and flame test. Now this is one where calculations kind of throw people a little bit, so just kind of be patient. They do a good job, I think, working your way through this. But in terms of experiment materials, not a lot that you need. You need the spectroscope, you need forceps, your cups, just 1 10-ounce cup. You should have a package where it says flame test stick pack. You will see, it's like 5 sticks in here. Okay, so you have different colors. And you will have a flame source, so you'll have your ethanol gel. All right, so the first part of this, I'm going to walk you through, I think, activity 1 and activity 2, and then we will do activity 3 and 4 in the later session. Okay. All right, so what we're going to be looking at is, if you think of fireworks, why do you see those colors? Why do you see the blue in the night sky? Why do you see the green in the night sky? Okay. And that has to do with how the electrons are jumping within an atom. Okay. So if you look at a Bohr's model of an atom, you have different energy levels. Each energy level gets farther and farther away from the nucleus. So energy level 1 is closest to the nucleus. Energy level 2 is farther out. Energy level 3 is farther out. Okay. Each energy level corresponds to an N value, so the principal quantum number. And you should be familiar with that because we should have had that discussion by this point. Okay. So we can, if we know where the electron is, okay, and we know where it originates to, we can predict the wavelength, we can predict the frequency of that electron. We also know its energy value. And then therefore we can determine what color of light that we should be seeing based on those values. Okay. Remember that we're looking at a very narrow range of the electromagnetic spectrum. We're looking at an area between 400 to 700 nanometers. So it's a very, very, very small area in that spectrum. Okay. So on page 3 of your lab, okay, they've given you some calculations. Okay. Be familiar with what the variables represent. Okay. There is an equation where you look at the speed of light, and that speed of light is the product of wavelength and frequency. Okay. I can manipulate that equation, and looking at an energy equation, I can combine 2 equations together to come up with this equation in the top left-hand corner. Okay. So the change in energy, so how much energy an electron releases when it relaxes back down to a lower energy state, or how much energy an electron absorbed when it goes into the excited state, can be determined by this equation. Okay. H is Planck's constant, okay. So 6.63 times 10 to the negative 34th joules second. Okay. C is the speed of light, 3.8 or 3.0 times 10 to the 8th meters per second. Okay. Now remember that those units are in meters for speed of light. So your wavelength, which is the lambda value on the bottom, must also be in meters. Okay. So through cancellations, you should end up with an energy value that is going to be in joules. Okay. So with this lab, the very important thing, and even with the homework assignments, watch the units. Okay. All right, so we're going to be determining at the very end of this experiment where an electron originated from and where it should end up. Okay. All right, so the first part of this experiment, okay, is to take your spectroscope, okay, and you want to have the Carolina portion of the spectroscope facing up. You need to have your light source needs to be pointed in this little slit right here, so it should seem like a bright light. You need to focus that light on your source. And as you do so, you should see over in this section here a scale from 4 to 7. So 4 being on the left-hand side, 7 being on the right. And as you point this up to your light source, what you should see is something that looks like this, or potentially looks like this, okay? And I'm going to hide that bottom portion. Okay. So you should be seeing one of those two types of graphs. Either this one here, and your 4 is going to be on the left, so it's going to be 4 to 7 from left to right, or you're going to see this one here from 4 to 7. Whether you see the colors blended together or separate distinct lines. Okay. Now, these represent two different types of emission spectrums. One would be a continuous spectrum, one is going to be a light emission. Okay, so I'm going to let you decide and tell me what the difference is. So be thinking about that, because that is going to be a possible question that I ask you. Okay. So what you should see is, when I look through the spectroscope and I point this towards the fluorescent light, I'm going to see an image that looks like this. Okay. What you need to do is take your data table 1, okay, and you're going to, on here, they only ask for 3 colors. Okay. So they ask for, is it a line spectrum or is it a continuous spectrum? Okay. So I'm going to let you decide that. First color, first spectrum line color. Okay. I see violet. Okay. So I'm going to write violet on that line. Okay. First spectrum line number. Okay. If I read my scale, I read it at 4.4. Okay. So I'm going to write 4.4. Okay. Then I'm going to go down to second spectrum line color, okay, turquoise, okay, or teal. And it appears at what line spectrum number? According to what I see here, 4.9 to 5. Okay. And then the same, I would put green down at what looks like 5.4. Okay. So use this spectrum to fill out this table. Okay. Then you need to find 2 other sources. Be creative. Use a lamp in your bedroom. Use your headlights from your car. Look at the street lights. Okay. Use any other 2 light sources that you want to look at. Okay. All right. Now, I need to know if my spectroscope is calibrated correctly or not. So in order to do the next part, activity 2, I need this column of data right here. Okay. If you see more than 3 numbers, like here I see 5 colored lines, write down all 5. Okay. But the 3 from this column here, these 3 numbers, okay, must appear on this sheet. This is data table 2. Okay. So the 4.4, the 4.9, and the 5.4 that I got on data table 1, I put in this column right here, 4.4, 4.9, 5.4. Okay. But I saw more than 3 lines. Okay. I saw a total of 5 lines when I looked at the fluorescent light. Okay. So I'm going to go ahead, and if this was my fluorescent light sample, okay, I'm going to go ahead and I'm going to write down the other 2 lines. Okay. Okay. Purple is a very hard color to see. Okay. It blends in with the black background. So you may only see 5 of the 6 colors, or you may see all 6. Okay. But I want to see every line that you see, so every numerical marking here. Okay. Then, and I didn't fill in this color part here. You can, based on these colors here, you would fill in that color section right here. So 6.2 would be red, 5.9 would be orange, 5.4 green, turquoise, and violet here. Okay. All right, now where I got these numbers here, this column here, is from data table, is from the table 2 in your experiment. Okay, so refer to page 5 of your lab. All right, so 4.4, that was a purple color, so I assigned that wavelength to be 405.4. 4.9, if that was my blue color, then I would write 436.6. Turquoise had a line scale number of 5.4 according to that spectrum that I saw, but that corresponds to a wavelength of 487.7. Okay. So what that's telling you is that in your spectroscope here, whenever you see a purple line, you should be looking for a wavelength somewhere in the 400 nanometer range. Okay, if it lines up perfectly with 4.4, that's the wavelength. Okay? If it's 4.5, the wavelength is going to be a little bit different. Okay, but you should still be in that vicinity. Okay? We're calibrating the wavelength of, we're calibrating our spectroscope, because what I'm going to do here is I'm going to take these two columns and I'm going to make a graph, and it needs to be in Excel. Okay? So look in your experiment, look in your instructions for this lab. Your instructor has included the links of how to make an Excel graph. Okay? This column here, as they state in the instructions, is your y-axis. This column here is your x. Okay? So you're going to plot these. You're going to determine the best fit line. So you're going to get the trend line. And it would also be very helpful if you get the equation from that. Okay? All right. So the next part of this, we will continue on with the flame testing. Okay? For the next part, I need to fill my cup up with water here. So I'm going to fill this up with water. I'm going to cut these sticks into 4 separate pieces. Okay? And then I'm going to put them in water and let them sit. Okay? The idea is that by letting them sit in water, when we look at the flames of so when I look at the flame for here, the wood is not a factor. Okay, so you're just burning the chemical and not the wood portion. Okay. All right. So the next time I'm going to have these sticks cut up into 4 pieces, and one thing that you can do while you're letting your pieces of wood sit, okay, to help keep myself organized, I went ahead and labeled what color was what stick. So purple color was potassium chloride, red was lithium chloride. This just made it a little bit easier for when I get to that point. But when we come back, I will have let these had a chance to sit in water, and we will be ready to flame test. So come back and we'll see you in shortly.